Hey everybody, welcome back. I'm Bud Churchward, WB7FHC, and it's been a long time since I've been on a video here, so sorry about the delay, but I think we have a real interesting one for you today. Just a few days ago, the Mount Baker Amateur Radio Club's digital group had a workshop. I recorded that session and decided it would be useful to break up that footage into a series of videos of helpful information that would be handy for people who are having issues or trying to learn how to better use their Nexus DR-X digital radio cross patch. In this first session, we're going to take a look at the options that we have of controlling our radios while we're running FLdigi. There are several options to look at, and we'll see how they're configured, and we'll look at some of the issues. Most of the options that are available, for example, RigControl, are geared primarily for use with the HF radios, and they do a really good job of doing that. Here in the northern corner of Washington State, in Whatcom County, we have quite a group of people who use digital radio communications on the VHF band. We're running FLdigi on 2 meters, and we're having a lot of fun doing it. So when it comes time to control your radio using something like FLrig or RigControl, these programs, which were great with the HF radios, run into an issue because typically our VHF UHF radios have a double side to them. There's an A side and a B side, and when we start trying to control these radios remotely with software, we run into some issues. So what works really, really well with HF can have some problems when we're using, for example, our Kenwood 710 radios or the Kenwood 71A. So we're going to take a look at how we can solve those problems, and I think you'll enjoy this. Stick around. If you'd like your own Nexus DR-X kit, go to WB7FHC.com to find all the details.
Okay, so I'm going to share my VNC session to my Raspberry Pi. Do you see that?
Yes.
Okay.
So would it be appropriate to try to do what you're doing?
Sure. You can follow along at home. All right, so most of you are going to have your taskbar at the top of the screen. I've moved mine to the bottom. Some of you may have already done that. But the default is that it is at the top. But anyway, so the question, I think Andy brought up the question about using FLdigi, are specifically RigControl and FLdigi for the Kenwood TM-V71A or the 710. And I can tell you that it doesn't work very well. And I think the reason for that is that it is twofold. Number one, RigControl in FLdigi and in the other RigControl applications is specifically designed for HF rigs. And it doesn't really understand the concept of radios that have two sides very well. And it especially doesn't understand the concept of designated one side of the radio for digital purposes. It just doesn't, it doesn't get that. So the typical FLrig controls, which is FLrig is another program in the FLdigi suite, are designed for HF radios, and it works extremely well on many HF radios. I have an ICOM 7100, and it has unbelievable control over almost every aspect of the radio. And I know that's true with other HF rigs as well. But when it comes to the implementation for VHF, UHF radios, especially those that have two sides to them, it falls on its face, sort of. So I'll dive in here and I'll show you what I mean by that. So down here in my taskbar, I have placed the FLdigi for my Kenwood I'll turn my radio on here. And the way you set up the way you set up RigControl and FLdigi is you click Configure, Config Dialog, and you go to RigControl. And you have several options here. FLrig, which is the preferred way of interfacing your radio to FLdigi. You have CAT or RigCat, as it's called, which uses an XML file, which is basically a configuration file that some other ham or group of hams has put together that tells FLdigi how to interface with that radio. And on the W1HKJ's website, there are a list of XML files that you can download and load into FLdigi that will allow you to interface directly with the radio. So there's no need to have FLrig in that case. The FLdigi in that case communicates directly with your radio. The third one is GPIO, which isn't really RigControl, it's push-to-talk control. And that is the default setting for the Nexus. It doesn't change frequency, it doesn't do anything but activate push-to-talk. And that's the way that we, by default, FLdigi is set up to interface with, for example, the Kenwood or any other radio. Okay. The next one on the list is HamLib, which is a standalone product. It's also installed in the Nexus that communicates with a variety of radios, and among them is the TM-V71, 710G. That's also what you select if you happen to be using a TM-V71A. The command set is the same for both. However, the 71A isn't separately listed. So you would select the 710 if you have a 71A. The next one is hardware push-to-talk. And again, this is not really RigControl. It's only push-to-talk. And this is a way to use a serial connection, something that you would probably make homebrew and wire to the push-to-talk interface on your radio, whatever that happens to be. We usually don't, I have never used this, but I'm sure that some hams do, otherwise it wouldn't be a feature in FLdigi. The way that they've implemented RigControl in FLdigi is somewhat confusing, because on this hardware push-to-talk, you can see there's also a GPIO push-to-talk that replicates what's in the GPIO tab here. So this setting here and this setting on this page are the same. So if you toggle it here, it will toggle it on the other page. I'm not sure why it appears twice, but that's just the way they chose to implement it. And the last one in the list is also only push-to-talk, and it has to do with this C-Media USB interface. There are these $8 USB sticks that are actually audio cards that have a chipset in them that if you are an extremely good solderer, you can, Rob is holding one up there. They're very tiny. If you are very good at soldering, you can actually tap a GPIO pin inside that USB device and use it for push-to-talk. And this is quite popular, I understand. And FLdigi gives you some control over using that if you choose to implement that. Okay. But anyway, back to the GPIO setting. This is the default. Now, to some extent, using GPIO and using RigControl to change the frequency and maybe other settings of the radio can be used at the same time. So in other words, you can use GPIO to activate push to talk, and you can use RigControl to change the frequency, both at the same time. But like I said before, it doesn't work all that well with the Kenwood radio. Okay, so let's go back to the FLrig setting for a minute. The way FLrig works is it's a separate program that you run, and FLdigi communicates with that program over a TCP/IP connection. Now, since they're running on this, since FLrig, in most cases, FLrig and FLdigi are running on the same computer, they communicate through what's known as a loopback interface. This is like an internal network interface that exists on all Linux computers and all Windows computers and Macs. It's common across all operating systems. And it just communicates via a TCP/IP network connection to FLrig. Okay. So the way that the write radio is set up in my case is it's communicating to the loopback interface, which has this IP address, and it's communicating to it on this TCP port. Now, since I'm not running FLrig at the moment, you know, it uses this default frequency up in FLdigi of 14 megahertz or so. Okay. However, if I start FLrig on my Kenwood, okay, you can see that I have already set up FLrig here, and it is talking to my radio. The reason I know that is because I'm actually looking at my radio and I see that it has indeed changed the frequency and so on. So if I change the frequency on my radio, you can see it changing in FLrig. Okay. So I'm actually turning the tuning knob on my radio to make that change. So a little bit of an aside now. Let's focus on the actual FLrig configuration. When you first start FLrig, if you don't already have a rig set up, there's a rig called none in there, which is sort of a placeholder. And you have to go in and start and into configuration and set up your transceiver. And there's a drop down here where you select your radio model. And again, the TM-V71A is not listed, so you select the TM-D710. They use the same command set. You specify your serial port here. So you have to know the serial port that your computer is using to talk to your rig. In my case, I have quite a few serial ports that FLdigi thinks there's, not all of them are serial ports, but FLdigi thinks they might be, so that they prints all of them. And the one I know is my serial port connected to my rig is this one here, so that's the one I've selected. I set my baud rate. It's 1 stop bit, and request to send and clear to send is checked. These are important parameters that you get by reading the Kenwood manual. Okay, it says in there that this is these are the settings you need to use. The baud rate is configurable, and it has to match what your radio is configured for. I typically use 57600. These settings you don't need to mess with usually. These are the default settings, and I found that they work okay to communicate with the rig. And you can see that it's connected. Okay. Now, within FLrig, there are similar settings to settings that are in FLdigi. There's PTT generic, there's PTTC media, all sorts of things in here. Under server, you can see this XML RPC port 12346. That has to match this field in the FLdigi configuration. So FLrig is running as a server and it's listening on this TCP port. That means that the client, FLdigi, which wants to talk to FLrig, has to initiate a conversation on that same port. Okay, is that clear how that works? All right. Okay, now you'll notice I started FLdigi before I started FLrig. And so I don't see FLdigi updating its frequency here to show that it is indeed communicating with the FLrig instance. Typically, I have to do this, and you can see what happened there. It just closed FLdigi, it crashed. This is fairly common with this radio. I don't know why, but I have this problem a lot with FLrig on this particular radio. So let me start FLdigi again here while FLrig is running. Okay, and you can see it's still not working. It's not updating the FLrig or the FLdigi configuration in my here. Now, the reason for that, in this case, I need to go into FLrig and I need to tell FLdigi to use FLrig for RigControl. Okay, and there's another option here that says FLrig push-to-talk keys modem. So what this means is that if you check this box, FLdigi will send a cat command, or actually a push-to-talk command via XML to FLrig, which will translate that into the correct Kenwood code to activate push-to-talk. Okay, so if I check this box, it's going to use cat to control push-to-talk. It won't use GPIO. However, if I leave this unchecked and I go back to my GPIO settings, which I already had, and this was the default, you can see that this is checked and I have the correct GPIO pin set here. So in that case, what's going to happen is that the Nexus GPIO pin is going to essentially make a path to ground through the mini DIN 6 connector on your Kenwood and use push-to-talk activation in that way. It won't use cat. Okay, so that's the way I'm going to set it up here. I've checked this box. And as soon as I checked that, I didn't even have to click reconnect. And you can see now that my FLdigi is showing the frequency that's shown in FLrig here. And theoretically, I can change frequencies and it'll update FLrig and FLdigi. Okay. So far, so good. If I save this setting now and close it, I should be able to still have, and so a word of warning, obviously I don't want to be on this frequency. So FLrig has the concept of VFO-A and VFO-B, which is, I would call them HF terms, but that represents side A and side B of the Kenwood. So if I click to side B, I'm now on 145.580. Here's where the first of many glitches occurs. As soon as I toggle this to side B, As I look in my radio, I've noticed that the push to talk and control settings of my radio have now moved to side B. That means that if I'm not observant and I pick up my microphone and I want to have a voice conversation on side A, that it's actually going to go out on side B. This is extremely annoying. Okay. What I want to happen is I want to leave push to talk and control functions of the radio itself on side A, so I can do voice comms through a repeater, for example. Now I have to be conscious of the fact that the push to talk and the control are on the B side of the radio, so I have to go to my radio, manually move them back to A, and now I should be good to go. Okay, so if I click transmit here, it's going out on the B side, which is correct. Now now this works because I'm using GPIO push to talk. Had I selected CAT push to talk, when I activated transmit receive here, it would have gone out on the A side of the radio because that's the side of the radio that PTT is on currently. So you can see where this gets very confusing. Okay, and it was such a frustration for me that I just abandoned it. And that's why I use my own script, the 710 script, that I just have running up and running all the time. And that way I can see visually that data is on side B, which side push to talk and control is on. I don't even have to be in front of the radio. And it just works fine. The drawback, of course, is that it doesn't update the frequency display here in FLdigi. But since you're running it, you'd be running it anyway, you know, really doesn't matter. So what I'll give you a demonstration of what I'm talking about here. I'm going to go back into my FLdigi configuration. I'm going to shut off RigControl for FLrig and make sure all these other ones are shut off too. This one's disabled. GPIO is still enabled. That's good. HamLib is off. These are all off. With the exception of this here, which reflects what's in the GPIO panel, and this one is off here. So I'll save this. Okay, and close this, and I'm going to close FLrig since we're not using it anymore, and then I start my own program here. The other thing to remember is that I cannot be running FLrig and this script at the same time because only one application can be communicating with the radio over that serial port at a time. So if you're running FLrig, you can't run this. If you're running this, you can't run FLrig, you can't run HamLib or any other RigControl application. Okay, any questions on that? Okay. All right, so the other option, I won't actually go through this one, but I'll just explain what it is. This is the HamLib configuration in FLdigi. Another option for using RigControl. Again, there's a list of rigs that are supported. You tell it which serial port to communicate on. You set the baud rate, all this other stuff here. Select request to send, clear to send. And what this does is it starts another application called RigControl, RigCTL, in the background that communicates over the serial port. Again, you cannot have your script running here and be running HamLib at the same time. They cannot be talking to the same serial port at the same time. Now, this doesn't work very well at all. When I enable HamLib here, This display never updates. It should, but it doesn't update here. So there's really no advantage of using HamLib over using the 710 script. Okay. The other option, I'll go back to this one here, is cat RigControl. And let me open a browser here. I mentioned that you have to put a rig description file, which is an XML file. And if I go to kj.com, this is the official website for FLdigi. And if you scroll down here to the SourceForge mirrors, files mirror, and you go to XMLs, you'll see a list of radio brands here, and under Kenwood, there are a couple of XML files. Two of them relate to the 710. Okay, and what you do is you download this file and you save it somewhere, and then you go back into FLdigi and you select that file here, you set up your serial ports, and you can do RigControl that way. That does actually change the frequency here, much like FLrig does, but it suffers from the same anomalous behavior of moving push-to-talk and control to the wrong side. It also has the irritating habit of changing FM to narrow FM. It has the irritating habit of changing the power from whatever you have it set to high. And unless you're observant, you wouldn't even notice these things. So another reason, and I'm sure these are just bugs in the software, but just another reason that I avoid using RigControl on this. Now, having said all that, I also have an ICOM 7100. It works beautifully with RigControl. And there's no need for another script. There's no need for external control. It just works wonderfully with that. And there are many other rigs, primarily HF rigs, where FLrig works great, and HamLib works great. But on these, like I said, on these radios, they don't work great with radios that have two sides, typically VHF, UHF radios that have two sides, and you're designating one side for digital operation. So if I've done nothing else this morning, I hope I've convinced you not to use RigControl on your on your 71A or your 710. Yeah.
I mean, I have made extensive use of both your 7110PY and your 7110SH programs. What I've found is that using YAD and, one of the other, your scripting tools that, you kind of introduced to me to, is that I've set up some scripts that actually allow me to use the 710SH to just go to specific configurations on the radio that I want. Mm-hmm. And then, so I can just call those scripts. And if I'm at a loss and I don't know what else to do, what I do is I call your Pi script, and that then gives me complete control of the radio. And I can do all those things because when I'm not running your Pi control program, I can run these scripts. So I've got great flexibility in terms of being able to use the tools you provided. And it really makes things much easier for me now, because I don't have to fiddle a knob anywhere.
Right. Yeah. And that's exactly why I wrote this thing. It was my frustration with the RigControl capabilities for this particular model that led me to write this Python and the shell script.
And the Python uses the shell script, right?
It's the other way around. The shell script uses the Python script, but yeah. Mm-hmm.
Okay.
Yep. It's like I said, it's a real frustration because I'm not sure if the authors didn't think through how it should work with the radio where one side is designated as digital, or I'm not really sure what the reason is for it, because there are ways around it. And actually I've thought about modifying this Python script so that it looks like FLrig to FLdigi, because there's a published interface that FLdigi uses. It's an XML RPC interface, and I could do that on sort of make this script look like an FLrig interface to FLdigi. Some time ago, when I first got involved with FLdigi, I was disappointed in the fact that my IC7100 didn't work well with FLrig. And Dave Reese, the lead developer for the FLdigi suite, is a really nice guy. And you know, it's unbelievable the amount of work he puts into these applications, but he does have an enormous amount of help. He has a lot of people all over the world who submit patches and help him write code and so on. And I started to work with him on the IC7100 because I was bound and determined to fix all the dozen or so quirks with it to make it work reliably with the 7100. And he was wonderful to work with. We would exchange, you know, I would modify his source code and I would submit a patch, and then he would test it and send it back. And he would, sometimes he would introduce a new bug, or I would introduce a new bug, and we'd go back and forth. But that's what it takes to make these rigs work with FLrig. It takes a community of people who actually own the rig to test them out and make sure they work. So it's not surprising that there's all kinds of quirks with RigControl, because it just takes a lot of time and a lot of effort on a lot of people's part to make it.
And hey, don't forget to subscribe, like, and share.